channel. Hi guys and welcome to yet another interesting video by Simply Learn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. Now without further ado, let's take a look at the agenda for today's session. To begin with, we will look into what is the user datagram protocol, continuing with knowing some features of the protocol, moving on with header format of the protocol. Next, we will look into the working steps of the UDP protocol, applications of the UDP protocol, and in the end, we will look into UDP versus TCP protocol. Let's move on with the first heading, that is, what is user datagram protocol? The user datagram protocol, commonly known as UDP protocol, is designed to be unreliable and connectionless in nature, which applies process-to-process communication model for data exchange between devices and is active in the transport layer of the HOSSAIN model and is used to transfer data and information related to internet services over the network channel, where process-to-process communication refers to the use of port numbers in the header format during the transmission of data over the network channel. As for connectionless, it means that the UDP format does not provide an established path for the data to transfer. Instead, it uses multiple different paths, which we will look into further in the video. Let's move on to the next heading. Features of using user datagram protocol. The user datagram protocol provides the network with various efficient and easy to understand network protocol features to apply over the data that is to be transmitted, where the first feature of UDP is related to the working area. That is, the UDP model is a transport layer protocol of the HOSSAIN model and is used to deliver best effort delivery options for the data transmission, where the best delivery option refers that the protocol does not provide the sender will receive any acknowledgement from the receiver side for the data transmitted, or it does not provide any guarantee of data transmitted to the receiver side. Now let's move on to the second feature of user datagram protocol. The second feature represents the mode of delivery or connection that the UDP establishes for data transmission. The UDP protocol, as we know already, establishes a connectionless path. That means there is no actual virtual path for the data to be transmitted, so that each data from the UDP format uses a random path available in the network channel and reaches its destination. Now let's move on to the next heading, that is UDP header format. The UDP header format comprises of two parts. First, the UDP header part, which is 8 bytes in size, and second, the data to be transmitted. Furthermore, the header part is divided into 4 different parts: source port, destination port, total length, and checksum, where each of the parts are divided into 16 bits. Let's take a look at the different parts of the header format in a little detail. The first one is source port number. It is a 16-bit value that is used to identify the port that is transmitting the data. Next is destination port number. That is used to identify the port number that will be receiving the data on the receiver end. Next we have total length. As the name suggests, this value is used to specify the total length of the UDP packet, including the UDP header part. And the last is checksum. This is a 16-bit value field and is used as an optional attribute. It is left empty if there is no need, or it is used in case where accuracy of the data is to be measured. Now let's move on to the working of the UDP protocol. To begin with, we have data from the sender side, which is enclosed with the UDP header for communication and data in the UDP header part. The next step is to hand over this data over to the IP section for encapsulation, with the IP header and data with the UDP header and data part. As for the last step, this part is handed over to the frame section, where it is transformed with the frame header and data format. Moving on, now let's transmit the data over the network channel for the receiver end to receive it. Over to the receiver side, first step is decoding of frame header part and data part into the IP section, which contains IP header and data section. Again, this IP packet is divided into UDP header part and data part, from where the message is retrieved from the data section of the UDP header format and is then received by the receiver end. To the applications of UDP protocol. Let's take a look at some of the features of the UDP protocol that provides applications to various network models. For the first one we have, it provides flow control and error control mechanisms to the network model such as TFTP. Next, it provides faster transmission of data as there is no pre-established virtual path needed. So it is used for real-time services, live communication, and gaming services. Now let's move on to the last setting for this session, that is UDP versus TCP protocol. We will differentiate between UDP and TCP based on some attributes that are mostly used in a network model. And the first attribute is reliability. For UDP protocol, as we already know now, it is unreliable in nature. That is, it does not provide any guarantee of data transmitted to the destination side is reached or not. As for TCP, it provides reliable and guaranteed data delivery to the receiver side. The next attribute is acknowledgement signal. The UDP protocol does not provide any acknowledgement from the receiver side to the sender side. Whereas in case of TCP protocol, sharing the acknowledgement signal is very important. If the acknowledgement